In 1969, the gates of the American Locomotive Company plant in Schenectady, New York, closed for the final time. The fires in the foundries went cold. The assembly bays fell silent. A manufacturing empire that had built over 75,000 locomotives, machines that literally laid the physical tracks of American commerce, was systematically dismantled. 30 years earlier, ALCO possessed a near monopoly on American motive power. If freight moved across the continent, it moved behind a boiler cast in Schenectady. The Pennsylvania Railroad relied on them. The New York Central championed them. But the real story of ALCO's collapse in the American market is not about a sudden lack of demand for locomotives. It is the story of what happens when a culture of bespoke, traditional mechanical craftsmanship collides with the relentless, standardized mass production machinery of Detroit. It is the story of the Electro-Motive division of General Motors, and how the pursuit of a standardized diesel engine crushed the greatest heavy engineering firm in American history. Every week, we tell the stories of the machines that built the American century and the brutal market forces that eventually tore them down. Subscribe if you believe these industrial monuments deserve to be remembered. The story of ALCO's collapse begins not on the scrap lines of Schenectady, but decades earlier, in the final undisputed triumph of American steam. In the summer of 1901, 8 independent American locomotive manufacturers merged to form a single industrial titan. They called it the American Locomotive Company, soon abbreviated to ALCO. Headquartered in Schenectady, New York, the massive new conglomerate inherited a tradition of heavy iron and boiling water. Over the next 3 decades, ALCO would forge over 40,000 steam locomotives. They built machines that moved the coal out of Appalachia, machines that hauled wheat across the Great Plains, and machines that dragged the nation into the 20th century. In the rail yards of Chicago and the passenger terminals of New York, the ALCO builder's plate was not just a manufacturing stamp. It was a declaration of supreme mechanical authority. The culture at Schenectady was rooted in the artisan tradition of the 19th century, scaled up to industrial proportions. Railroads did not buy standard products off a catalog. A motive power superintendent from the Pennsylvania Railroad or the New York Central would arrive at ALCO with a highly specific list of demands. They wanted specific wheel arrangements, exact boiler pressures, and custom firebox dimensions tailored to the exact type of coal their region produced. ALCO's engineers obliged. Every locomotive class was a bespoke creation. A custom-built Pacific-type locomotive in the 1910s might cost $30,000, roughly $900,000 today. The manufacturing process relied on massive foundries pouring molten steel into unique sand molds, a slow, labor-intensive method that elevated craftsmanship over efficiency. But by the 1920s, American railroads were suffocating under the weight of their own steam infrastructure. Steam locomotives, engines that burn coal or oil to boil water and drive heavy pistons, were magnificent to watch, but ruinous to operate. Their thermal efficiency rarely exceeded 8%. They required a staggering, continent-spanning network of coal towers, water columns, ash pits, and massive roundhouses just to keep moving. A steam locomotive spent hours out of service every day having its fires cleaned and its boiler washed. American commerce was expanding, but the railroads were tethered to an archaic, maintenance-heavy power source. They desperately needed a machine that could simply be switched on and put to work. ALCO recognized this gap early. In 1924, they partnered with the General Electric Company for traction motors and Ingersoll Rand for an internal combustion power plant. Together, they produced the first commercially successful diesel-electric switcher in the United States. A switcher, a compact locomotive designed exclusively for moving and assembling rail cars at low speeds within a train yard, was the perfect test bed. In 1925, the Central Railroad of New Jersey purchased the first production unit for their isolated yard in the Bronx. The price was roughly $95,000, equivalent to about $1.6 million today, and vastly more expensive than a comparable steam engine. Yet, the economics worked. The new diesel did not produce the choking black smoke that had triggered strict anti-pollution ordinances in New York City. More importantly, it did not need to drop its fires or take on water. It operated continuously, day after day, requiring only occasional refueling. Trade publications like Railway Age quickly noted its high initial cost, but praised its remarkable availability. By 1930, ALCO had dominated the early niche market for diesel switchers. They had the patents, the partnerships, and the pedigree. But ALCO made a fatal philosophical miscalculation. The management at Schenectady viewed the diesel engine strictly as an auxiliary tool, a specialized machine for urban switching duties or light branch line work. They could not conceive of a world where a diesel could replace the brute mainline hauling power of a massive steam locomotive. Throughout the 1930s, even as they refined their diesel designs, ALCO continued pouring its primary capital, engineering talent, and factory floor space into building the largest, most complex steam locomotives the world had ever seen. They believed custom steam was eternal. While ALCO was pouring custom steel in New York, a very different philosophy was taking root in the automotive capital of the world. In 1930, General Motors purchased a small rail car builder called the Electro-Motive Company, along with the Winton Engine Company. General Motors did not care about the romantic artisan traditions of steam railroading. They brought the cold, calculated logic of the Detroit assembly line. They intended to standardize the locomotive, mass-produce it using identical, interchangeable parts, and sell it in volume. By 1939, GM's newly formed Electro-Motive division, or EMD, opened a sprawling, modern manufacturing facility in LaGrange, Illinois. That same year, EMD sent a 4-unit, 5,400 horsepower diesel-electric demonstrator known as the FT on an 83,000-mile tour across 20 major American railroads. The FT proved definitively that a standardized diesel could haul heavy mainline freight faster, cheaper, and with less track wear than any custom-built steam engine. And crucially, EMD did not ask railroads what custom features they wanted. They offered a standard catalog model. If a railroad needed more power, they simply bought a second identical unit and coupled it to the first. ALCO suddenly found itself fighting a war on two fronts. They were defending an obsolete steam infrastructure against a vastly superior technology, and they were defending a bespoke manufacturing culture against the greatest mass production machinery on Earth. The engineers in Schenectady realized they had to pivot to mainline diesel production immediately or perish. They had the facilities, they had the workforce, but they lacked the one thing General Motors had perfected: the discipline of standardization. The end of the Second World War left ALCO at a severe disadvantage in the American market. During the conflict, the federal government's War Production Board had strictly regulated industrial output to maximize military efficiency. The board permitted General Motors EMD to continue building heavy mainline freight diesels, recognizing their standardized efficiency. Conversely, they ordered ALCO to concentrate on what they already did best: building traditional steam locomotives and small diesel yard switchers. When the wartime restrictions lifted in 1945, EMD possessed a 4-year monopoly on mainline diesel manufacturing experience. ALCO was dangerously behind, and American railroads were suddenly desperate to replace their exhausted, war-weary steam fleets. To survive, ALCO had to execute a massive technological leap. They could not simply match EMD. They had to offer a distinct, compelling alternative that appealed to the traditional heavy railroading sensibilities of American motive power superintendents. In 1946, ALCO launched their counterattack. They introduced a brand new high-speed passenger locomotive known as the PA, alongside a highly versatile freight locomotive known as the RS2. The ALCO PA was designed to be the ultimate American passenger flagship, Physically, it was a masterpiece of industrial design. Where the competing EMD units featured a rounded bulldog-like snout, the ALCO PA featured a massive, flat, squared-off nose, sweeping side panels, and a towering profile. It did not look like a scaled-up automobile. It looked like a machine built to pull heavy steel across a continent. Underneath the glamorous exterior lay a fundamentally different approach to generating power. EMD utilized a two-stroke diesel engine, which fired every time the piston reached the top of the cylinder. ALCO bet their future on a four-stroke design, introducing the all-new Model 244 prime mover. To generate enough horsepower to compete with General Motors, ALCO engineers equipped the 244 engine with a turbocharger. A turbocharger is a mechanical fan driven by the engine's hot exhaust gases. It spins at high speeds to force dense compressed air into the combustion cylinders, creating a more powerful explosion and extracting massive horsepower from a smaller engine block. The mechanical power generated by the massive V16 engine was then converted into motion using a diesel-electric transmission. In this system, the diesel engine does not physically turn the wheels. Instead, the engine spins a massive main generator, creating direct current electricity. This electricity is fed through thick cables down to traction motors, heavy electric motors mounted directly onto the wheel axles, which actually drive the locomotive forward. At a purchase price of approximately $160,000 in 1947, roughly $2.2 million today, a single ALCO PA cost roughly the same as an EMD passenger unit. But ALCO offered a distinct mechanical advantage. Their electrical transmission components were built exclusively by the General Electric Company. GE's traction motors were universally respected in the railroad industry. They were heavily insulated, massively overbuilt, and capable of sustaining higher continuous tractive effort than competing designs. Tractive effort is the raw, physical pulling force a locomotive can apply to the rail before its wheels slip or its electric motors overheat. For an American railroader dealing with the steep, brutal grades of the Appalachian Mountains, GE electrical gear was a powerful selling point. While the PA hauled the glamorous passenger trains, ALCO's true structural breakthrough in the American market was the RS, or Road Switcher series, culminating in the wildly successful RS3 in 1950. A road switcher is a locomotive built with a narrow hood covering the engine compartment and exterior walkways on both sides, rather than a full-width enclosed car body. General Motors was busy selling F units, which were essentially enclosed boxes with a cab at one end. An F unit had to be driven forward. If a crew needed to back up or switch individual freight cars in a yard, the engineer had to lean precariously out the side window to see. The ALCO road switcher solved this visibility problem entirely. The narrow hood allowed the engineer to look clearly in both directions. An RS3 could haul a heavy local freight train at 60 miles per hour down the main line, arrive at a rural manufacturing plant, and immediately begin precisely sorting boxcars in reverse. It was the ultimate utilitarian tool for the American railroad, and it forced the entire locomotive industry, including General Motors, to eventually adopt the road switcher configuration. Major American railroads responded to ALCO's new catalog with massive orders. The New York Central system, fiercely loyal to ALCO during the steam era, purchased fleets of PAS to pull their elite passenger trains out of Grand Central Terminal. The Atchison, Topeka, and Santa Fe Railway painted ALCO PAS in their iconic red and silver war bonnet scheme to haul the Super Chief across the southwestern deserts. The Southern Pacific ordered them for the daylight runs up the California coast. The Pennsylvania Railroad, a notoriously demanding customer that required immense heavy hauling capability, bought both the passenger models and the road switchers. The Delaware and Hudson, ALCO's hometown railroad, dieselized its entire operation almost exclusively with RS units. By 1950, ALCO had effectively reinvented itself. They had closed the gap with General Motors. They had introduced the turbocharged four-stroke diesel to the American main line. They had established the road switcher as the standard configuration for American freight. The name on the builder's plate no longer just meant superior steam. It meant a viable, heavy-duty alternative in the new diesel age. By 1951, the American Locomotive Company had achieved what seemed impossible 5 years earlier. They had not only survived the abrupt, brutal transition from steam, they had carved out a massive, highly visible empire in the newly dieselized American landscape. The ALCO PA was no longer just a catalog offering. It was the physical face of post-war American luxury rail travel. The New York Central System ordered fleets of them, painting the towering units in their iconic two-tone gray lightning stripe livery to haul elite passenger trains out of Chicago and New York. For the Central, a railroad that measured its corporate prestige by the minute hand of a conductor's watch, trusting their flagship schedules to an ALCO diesel was a definitive endorsement. The PAs thundered down the water-level route, maintaining 80 miles per hour for hours on end, their massive General Electric traction motors running cool under the relentless load. Standing on the platform of Chicago's Dearborn Station or Los Angeles Union Station in 1952, a passenger waiting for a transcontinental streamliner experienced the absolute zenith of ALCO's design philosophy. The PA did not idle with the smooth, humming precision of a General Motors product. The four-stroke V16 turbocharged Model 244 engine possessed a distinct, throaty, rhythmic hunt. When the engineer opened the throttle, the massive turbocharger would spool up, emitting a rising mechanical whine, followed immediately by a thick, violent plume of black exhaust smoke as the heavy engine caught the electrical load. It sounded like heavy industry. It felt like raw power. To a generation of American travelers, the ALCO PA was the definitive sensory experience of the mid-century streamliner era. The success was not limited to the glamorous, high-speed passenger corridors of the East Coast. The Atchison, Topeka, and Santa Fe Railway purchased fleets of PAs specifically for their grueling, high-altitude southwestern routes. The Southern Pacific used them to conquer the steep grades of the California coast. The New York, New Haven, and Hartford Railroad ordered them to bridge the dense passenger network between New England and the Mid-Atlantic. In the freight sector, ALCO's dominance was even more pervasive. The RS3 road switcher became ubiquitous in every major rail yard from Boston to St. Louis. The Pennsylvania Railroad, the self-proclaimed standard railroad of the world, and historically the most demanding customer in the industry, bought hundreds of ALCO road switchers to drag heavy coal trains out of the treacherous Allegheny Mountains. The Delaware and Hudson Railway, operating in ALCO's own backyard in upstate New York, built its entire post-war corporate identity around the rugged, dependable ALCO hood units. The scale of production at the Schenectady plant soon rivaled the peak, frantic years of the steam era. Thousands of American workers manned the sprawling assembly bays, shifting their generational skills from pouring massive iron steam castings to assembling precision diesel prime movers and wiring miles of high-voltage electrical cable. The volume was staggering. Between 1946 and 1953, ALCO sold roughly 3,500 diesel-electric locomotives to American railroads, at an average price of roughly $150,000 per unit. Over $1.6 million today, this represented nearly $500 million in industrial revenue. They held a secure, highly profitable 25 to 30% of the total American locomotive market, in a heavily capital-intensive industry effectively controlled by the immense monopolistic gravity of General Motors. Holding a quarter of the continent's motive power was not just corporate survival. It was a spectacular triumph of traditional heavy engineering. The true measure of ALCO's triumph in the early 1950s was not found on the high-speed passenger corridors, but in the brutal, low-speed arena of heavy American freight. In this environment, raw horsepower mattered less than continuous tractive effort, the maximum pulling force a locomotive can sustain at low speeds without the thermal failure of its electrical components. General Motors' EMD locomotives were brilliantly standardized, but their traction motors possessed strict thermal limits. If an EMD unit was forced to drag a heavy train up a steep grade at 10 miles per hour for an extended period, its electrical wiring would overheat and melt. ALCO's partnership with the General Electric Company provided a massive competitive advantage. GE's traction motors were heavily insulated, vastly overbuilt, and designed for extreme abuse. On the grueling 1.75% grades of the Allegheny Mountains, where the Pennsylvania Railroad moved millions of tons of Appalachian coal to the eastern seaboard, a standard EMD freight unit would frequently falter under the low-speed thermal load. The ALCO road switchers could grind up the same mountain all day without exceeding their thermal ratings. For a motive power dispatcher trying to clear a congested mountain bottleneck with 10,000 tons of unrefined coal, the ALCO was not an alternative. It was a tactical necessity. This mechanical resilience allowed ALCO to carve out absolute regional fiefdoms across the American railroad map. The Erie Railroad purchased fleets of ALCO units to bridge the heavy manufacturing centers of the industrial Midwest. The Reading Company used them to haul dense trains of anthracite coal out of eastern Pennsylvania. The Boston and Maine Railroad relied on ALCO road switchers to conquer the punishing, snow-choked winters of New England. These mid-sized railroads did not have the vast financial resources of the Union Pacific. They needed a single, versatile machine that could pull a heavy freight drag in the morning, switch a dense industrial yard in the afternoon, and haul a commuter train at dusk. The ALCO RS-3 fulfilled every one of those mandates. To support this sprawling fleet, ALCO established a nationwide network of parts warehouses and maintenance facilities, stretching from North Bergen, New Jersey, to Los Angeles, California. They understood that a diesel locomotive was only profitable when its wheels were turning. Railroads required a constant supply of specialized replacement parts, fuel injectors, cylinder liners, heavy electrical relays to maintain the tight schedules demanded by the post-war economic boom. ALCO guaranteed that replacement components could be dispatched to any major rail yard in the country within 24 hours. By 1953, the American Locomotive Company had reached its absolute corporate zenith. The sprawling factory complex in Schenectady covered 112 acres and employed over 8,000 American workers. The production lines operated at maximum capacity, running 3 shifts around the clock to meet the immense backlog of domestic orders. Between 1946 and 1954, ALCO manufactured and delivered over 1,300 units of the RS-3 model alone, making it one of the most successful single locomotive designs in American history. Over 70 distinct American railroads operated ALCO motive power, from the elite Super Chief accelerating out of Albuquerque to a heavy ore drag crawling through the iron ranges of Minnesota, to a lone road switcher sorting boxcars on a humid siding in Georgia. The ALCO Builder's Plate was a fundamental fixture of the national economy. The company's annual revenue routinely exceeded $200 million, equivalent to over $2.3 billion today. The ALCO PA even became a fixture of American living rooms, as toy manufacturers like Lionel mass-produced miniature versions, cementing its squared-off profile as the definitive image of a modern train in the American consciousness. ALCO had successfully defended its territory against the greatest mass production company on Earth. They had preserved their heritage of heavy engineering while adapting to the diesel era. Railroad executives respected them. Crews preferred their visibility and their rugged electrical gear. To the industry analysts writing in the pages of Railway Age in the early 1950s, the American locomotive market seemed to have settled into a permanent, stable duopoly. General Motors would control the vast fleets of standard freight units, and ALCO would dominate the market for specialized road switchers, heavy grade operations, and premium passenger service. The transition from steam appeared complete. The future of the Schenectady works seemed mathematically secure, but the foundation of this massive industrial empire rested entirely on the mechanical integrity of a single piece of machinery, the ALCO Model 244 diesel engine. And deep inside the massive cast-iron engine blocks currently hauling the nation's freight, microscopic fractures were already beginning to form. The illusion of a stable, permanent duopoly in the American locomotive market shattered from the inside out. The American Locomotive Company had successfully captured nearly a third of the national market by the early 1950s, but that empire was built on a dangerously compressed engineering timeline. In 1945, recognizing they were years behind General Motors in mainline diesel experience, ALCO management made a fateful decision. They took the Model 244 prime mover, the massive V12 and V16 four-stroke engines designed to power their entire new catalog, and rushed it into mass production. They condensed a rigorous, industry-standard 5-year testing and refinement cycle into barely 2 years. They bet the entire century-old reputation of the Schenectady works on an engine that had never been proven over millions of miles of punishing American rail service. By 1953, the bill for that accelerated development came due. The technological disruption that ultimately crippled ALCO was not the transition to diesel itself, but the catastrophic failure of their specific implementation. The Model 244 engine possessed a fatal, inherent design flaw deep within its architecture. The issue centered on the crankshaft, the massive, rotating steel shaft running the length of the engine block that converts the up and down motion of the pistons into rotational force to drive the main electrical generator. In the 244, the main bearings supporting this immense piece of steel were inadequately designed to handle the extreme torsional vibration of heavy railroad service. When an ALCO locomotive was subjected to the continuous, brutal stress of dragging thousands of tons up a mountain grade, those vibrations amplified. The bearings rapidly deteriorated. The oil pressure plummeted. And then, without warning, the massive steel crankshafts would physically shear in half. When a crankshaft snapped inside a locomotive hauling a freight train at 50 miles per hour, the engine violently seized. The massive internal forces often punched connecting rods straight through the side of the cast-iron engine block. The locomotive died instantly. In the intensely choreographed world of American railroading, a mainline failure was not merely an inconvenience, it was a systemic crisis. A dead locomotive on a single-track mainline stopped all traffic in both directions. It delayed high-priority perishable freight. It wrecked passenger schedules. It forced dispatchers to scramble relief engines from yards dozens of miles away. In an industry where operating ratios and on-time performance dictated survival, reliability was the only metric that truly mattered. The maintenance issues cascaded. Beyond the catastrophic crankshaft failures, the Model 244 engine suffered from chronic water leaks. The seals between the cylinder liners and the engine block frequently failed, allowing cooling water to seep directly into the lubricating oil. The resulting sludge destroyed internal components and required the locomotive to be pulled out of service for weeks of extensive, expensive rebuilding. Railroad executives looked at their motive power ledgers and saw a stark, undeniable contrast. General Motors' Electro-Motive division was selling locomotives powered by the Model 567 engine, a two-stroke design that had been developed before the war, tested rigorously in Navy landing craft and submarines, and refined over millions of commercial miles. It was mechanically bulletproof. An EMDF unit could run for a month with minimal attention. An ALCO PA or RS3 required a constant, vigilant stream of maintenance. ALCO units began crowding the repair shops of the Santa Fe, the the Pennsylvania, and the New York Central, driving up labor costs and dragging down corporate profitability. The reputation for indestructible heavy machinery, forged by ALCO over 50 years of pouring custom steam locomotives, was dismantled in less than 5 years of diesel operation. But mechanical failure was only the first structural force aligned against Schenectady. The second force was the overwhelming reality of domestic diesel dominance, weaponized through corporate finance. General Motors was not just a manufacturing company, it was the largest corporation on earth, backed by a staggering, virtually limitless reservoir of capital. They utilized this wealth to fundamentally alter how locomotives were purchased in the United States. Historically, railroads bought locomotives using equipment trust certificates, a complex form of debt requiring significant upfront capital. General Motors bypassed this entirely by leveraging the General Motors Acceptance Corporation, or GMAC. GMAC was the financial arm of GM, originally designed to help consumers buy cars on credit. General Motors scaled this concept up to industrial proportions. Transitioning a railroad from steam to diesel required massive capital outlays. A fleet of 50 new mainline diesels cost roughly $8 million, nearly $100 million today. Railroads were notoriously cash poor, burdened by high taxes and heavy infrastructure costs. EMD arrived at the negotiating table offering zero down, low interest, long-term financing through GMAC. Furthermore, General Motors offered aggressive trade-in credits. They would take a railroad's obsolete, worthless steam locomotives, offer a generous discount on a new fleet of EMD diesels, and finance the rest at rates no standard bank could match. ALCO, operating as an independent heavy machinery builder without a captive, multi-billion-dollar financing arm, simply could not compete with the sheer gravitational pull of GM's checkbook. General Motors offered American railroads a flawlessly reliable, standardized product, guaranteed parts availability, and the loan required to buy it all. The retreat of the American Locomotive Company began quietly, in the procurement offices of their oldest allies. The Atchison, Topeka, and Santa Fe stopped buying ALCO passenger units, shifting their premier trains to EMD power. The New York Central, the railroad that had literally defined itself alongside ALCO, began placing massive, multi-million-dollar bulk orders for EMD road switchers. By the mid-1950s, the 30% market share that ALCO had fought so desperately to build was steadily, irrevocably eroding. They were losing the mechanical war on the rails, and they were losing the financial war in the boardroom. In 1956, the engineers at Schenectady attempted a desperate, massive mechanical correction. Recognizing the catastrophic flaws of the 244 prime mover, ALCO introduced an entirely new diesel engine design, the Model 251. The 251 was a spectacular piece of heavy machinery. It eliminated the fragile crankshaft bearings. It resolved the chronic water leaks. It was rugged, incredibly powerful, and highly fuel efficient. ALCO placed this new engine into a redesigned line of road switchers, and by 1963 they packaged it into the highly touted Century series, locomotives explicitly designed to recapture the American main line. Technologically, the 251 engine was a triumph. A properly maintained ALCO Century locomotive possessed superior adhesion, the raw physical grip between the steel wheel and the steel rail. Compared to equivalent General Motors products, it could pull more tonnage from a dead stop, but ALCO quickly discovered a brutal truth of American commerce. Engineering can be fixed in a single product cycle, but corporate trust takes decades to rebuild. The motive power superintendents at major American railroads had been badly burned by the earlier 244 engines. They had spent millions of dollars rebuilding shattered engine blocks and untangling congested main lines. By the time the flawless 251 engine arrived, Those same railroads had already committed their immense maintenance budgets to General Motors. The Pennsylvania Railroad, once ALCO's greatest patron, had standardized its training manuals, its spare parts inventories, and its repair shop tooling around the EMD two-stroke engine. Changing course again to adopt a new ALCO platform would cost millions in redundant infrastructure. Faced with tight margins, the railroads chose the safety of standardization. The 251 engine was functionally brilliant, but commercially, it arrived 5 years too late. Then, the final fatal blow arrived not from Detroit, but from ALCO's own backyard. For over 3 decades, the American Locomotive Company had relied entirely on the General Electric Company to manufacture its electrical transmissions. General Electric possessed an intimate, unrestricted view of ALCO's internal finances and dropping market share. GE management realized that tying their lucrative traction motor business to a failing locomotive builder was a severe corporate liability. In 1956, GE covertly began developing their own prime mover. By 1960, they severed their exclusive partnership with ALCO and entered the domestic locomotive market directly with the U-25B, a massive 2,500 horsepower road switcher known as the U-boat. General Electric did not just bring electrical expertise, they brought a corporate treasury and an international financing apparatus that rivaled General Motors. ALCO was suddenly caught in a vice between two of the largest corporations on the planet. General Motors commanded the established fleet replacements. General Electric commanded the high horsepower innovation and the electrical patents. ALCO, stripped of its GE partnership, was forced to source electrical gear from smaller suppliers, instantly losing the mechanical advantage that had once defined their heavy freight locomotives. Without a captive financing arm, without an exclusive electrical partner, and carrying the lingering stigma of past mechanical failures, ALCO's market share plummeted. They fell from a 30% share in 1952 to barely 3% by the late 1960s. The massive 112-acre Schenectady plant, designed to build 1,000 locomotives a year, was suddenly producing fewer than 100. The overhead costs of maintaining the sprawling 19th-century factory complex became entirely unsustainable. In 1964, the independent American Locomotive Company was sold to the Worthington Corporation, which later merged to become Studebaker-Worthington. The new corporate owners were not sentimental railroaders. They were conglomerate accountants. They reviewed the operating ratios. They analyzed the American market share. They looked at the immense, unassailable financial gravity of General Motors and General Electric. They realized that competing in the domestic locomotive market without a multi-billion-dollar financing structure was a mathematical impossibility. The retreat accelerated. Orders from major railroads vanished. The domestic production lines slowed. The parent company reviewed the ledgers again. The numbers offered no hope. In August 1969, the board voted. Locomotive production would cease entirely. The final domestic orders were canceled. The sprawling assembly bays fell silent. The drafting rooms emptied out. Thousands of mechanics were dismissed. The century-old foundries cooled. The heavy steel presses stopped. The gates were chained shut. The American Locomotive Company was gone. The American Locomotive Company did not experience a domestic corporate resurrection. When the board of directors ordered the cessation of locomotive production in 1969, the brand name was not lovingly preserved or relaunched by an American conglomerate. Instead, it was systematically dismantled. The intellectual property, the mechanical patents, and the manufacturing rights to the Model 251 engine were transferred across the border to the Montreal Locomotive Works in Canada, a former subsidiary. The engine designs were also licensed to overseas manufacturers, primarily in India and Australia, where the rugged, heavy steel philosophy of ALCO proved perfectly suited to developing rail networks. The ALCO prime mover went on to power thousands of trains across the globe. But in the United States, the commercial heart of the company ceased beating entirely. The name ALCO vanished from the order books of the American railroad industry. The foundries went cold. The corporation dissolved. Today, the survival of ALCO in America is no longer a matter of corporate commerce or mainline freight logistics. It is a matter of fierce, almost fanatical preservation. Across the country, a dedicated network of heritage railways, museum foundations, and private railfan syndicates spend immense sums of money to keep the surviving examples of Schenectady iron alive. At the Illinois Railway Museum, the largest operating transport museum in the United States, volunteers painstakingly rebuild early ALCO diesels, machining replacement parts completely from scratch because the original commercial supply chains collapsed 50 years ago. Tourist operations like the Cuyahoga Valley Scenic Railroad in Ohio, the Grand Canyon Railway in Arizona, and the Arcade and Attica Railroad in New York actively roster aging ALCO RS series and FPA units. In Oregon, legendary preservationist Doyle McCormick spent decades meticulously restoring an original ALCO PA locomotive, painting it in the iconic nickel plate road scheme to ensure that at least one of the magnificent, squared-off passenger units survived the scrap drives. These heritage operators and private museums do not use ALCOs solely out of romantic nostalgia. They use them because the fundamental engineering philosophy of the American Locomotive Company, massive, overbuilt components and superior low-speed adhesion, remains highly effective for the stop-and-start nature of modern excursion and short-line railroading. A 50-year-old ALCO road switcher can still grip a poorly maintained branch line track better than many lighter, newer locomotives. Furthermore, the acoustic experience of an ALCO is completely unique. The distinct, rhythmic throbbing of a four-stroke prime mover, followed by the rising mechanical scream of the turbocharger and the towering plume of thick black smoke as the engine catches the electrical load, is a sensory signature that no modern, computer-controlled General Electric or EMD locomotive can replicate. It is the raw, unrefined sound of mid-century American heavy industry preserved in working steel. If you visit Schenectady, New York, today, the physical footprint of that immense heavy industry has been largely erased from the landscape. The massive 112-acre manufacturing complex that once employed 8,000 American workers, the facility that forged the engines that won the Second World War and powered the post-war economic boom, is mostly gone. The sprawling erection bays where custom steam boilers were riveted, and the long assembly lines where diesel frames were welded, have been systematically demolished. In their place stands a casino, a community college campus, and a sterile modern industrial park. Only a few scattered brick facades, repurposed commercial warehouses, and fading painted signs remain. The physical epicenter of American custom rail manufacturing has been reduced to historical plaques and empty, quiet lots. The city that once built the machines that moved the nation no longer builds locomotives. Yet there is a profound, almost cyclical irony to the fall of the American Locomotive Company. It is a surprise footnote written in the ledgers of corporate history. The Electro-Motive division of General Motors, the untouchable titan of standardized mass production that weaponized corporate finance to force ALCO into submission, eventually met a similar fate. The American market shifted again. General Motors, facing its own massive corporate crises in the 21st century, spun off and sold EMD in 2005. The domestic locomotive market ultimately consolidated around General Electric, the exact company that ALCO had relied upon for its traction motors, and the exact company that covertly developed its own engines, severed its partnership, and abandoned ALCO to capture the heavy freight market for itself. The story of the American Locomotive Company is not simply a narrative of a massive engineering firm failing to adapt to a new prime mover. It is a definitive story about the fundamental, unforgiving nature of American capitalism. ALCO represented an older, artisan tradition of industrial railroading, an era where massive, complex machines were custom-built to perfectly suit the specific, demanding needs of an individual motive power superintendent. But the American commercial market, vast, ruthless, and heavily capitalized, does not reward bespoke craftsmanship at scale. It rewards standardization. It rewards the power of corporate financing. It rewards the machine that can be built identically 1,000 times and sold with a zero-down low-interest loan. The American rail network ultimately demanded financial efficiency over mechanical perfection. And in that brutal, calculated calculus, the custom builder was always destined to fall. But somewhere in the humid Pennsylvania countryside, on a quiet summer morning, an 80-year-old road switcher still pulls a string of heavy passenger cars up a steep mountain grade, its massive turbocharger whining, its overbuilt General Electric traction motors gripping the steel rail, the heavy iron of Schenectady still doing exactly what it was designed to do. See you in the next video.